derivatives of more exponentials and logarithmic functions. Objectives. By this lesson, you should be able to find the derivatives of general exponentials and logarithms. So before I actually write the definition of an exponential function, we talked about this a lot. It's just derivative of ex is e to the x. If you want to know why, like a lot of people ask me, the easy explanation is this right here. The derivative of a general exponential function. What if I just give you a generic exponential, right? Bx. That's all e of x is. It's an exponential function. It just happens to be the special number e. So the way we do the derivative of bx is you copy it, and then you times by natural log of the base. That is it. That's how you take the derivative of exponential functions. It's copy it times by natural log of the base. And that's written here. It's written a little fancier the way the book wants it, but this is the way I see it. You just copy it and times by natural log of the base. So what happens when I do that when it's e? Well, it's an exponential function, so you copy it, then times by natural log of the base. Base here being e. Well, natural log of e is 1, so you just get e to the x. That's why the derivative of e to the x is just e to the x. So that's the general form. That's the general exponential function, right? So if you want to take the derivative of general exponential, just copy it times by derivative of the base. That's why e is e. Now, what's going on right here? Well, these are just chain rules. That's all they are. So remember the way we do a chain rule? Take the derivative of the outside, which is this exponential function. So that means copy it times by natural log of the base. Leave the inside alone, g of x, and then times by derivative of the inside. That's all. Now, we'll do an example that makes more sense, but that's the general idea. This is the outside. This is the inside. So for a quick example, let's say I gave you 2 to the gx. Right? So we're going to take the derivative of the outside, which is the exponential of 2. So remember the way we do it? We copy it, and then times by the natural log of the base. And it's a chain rule, so we took the derivative of the outside, leave the inside alone, and then we times by derivative of the inside. That's the way it works. And there's the same thing for e, right? So taking the derivative of ex, so we copy it, e to the x, leave the inside alone, and times by derivative of the inside. So that's the idea. So the general idea here, guys, as long as you know chain rule, like this should just kind of follow, right? Take the derivative of the outside, leave the inside alone, times by derivative of the inside. The new thing here is the definition of a general exponential, which is just copy it and then times by derivative of the inside. So let's do some examples. Hopefully it'll make it easier. So our first one here. They want you to find the derivative of y equals 4x. So remember what I said? It's an exponential function, so we're going to copy it, then times by the natural log of the base. There we go. Now we have an e to the x. This is a chain rule, right? It's e to something, so it's a chain rule. So remember the way we do it? Take the derivative of the outside e, which is just e. Leave the inside alone, tan of x, times by derivative of tan of x. Remember, derivative of tan is secant squared. There you go. Some more. Let's do another e one real quick before we move on to that one. Take the derivative of the, right? It's another chain rule. Take the derivative of the outside. Leave the inside alone. Times by derivative of the inside. Derivative of the inside would be negative 1. So you also write it as negative e to the 2 minus t. Either of these are fine. As derivative of 2 minus t, 2 goes away. Derivative of negative t is just negative 1. Over here, find the derivative of 3 to the sine x. So it's another chain rule, right? So take the derivative of the outside. The outside is 3 here. So remember, all we do is we copy it, times it by natural log of the base, and then we got to times it by derivative of the inside. Derivative of the inside here is sine of x, which is cosine of x. And that'll be your answer. Right, so things are a little funkier, right? Take the derivative of the outside, which is the exponential function. So you copy it, 3 sine x, times by derivative of the inside, sorry, derivative of the base, then times by derivative of the inside. So that's why I do it. So those are exponential functions. Next up, how do we do natural log and logs? So again, I'm going to start down here with the general one. So the derivative of log, all we do is we're going to flip it to 1 over x, 1 over whatever the function is, times by the natural log of the base on the bottom. So 1 over natural log of the base. So real quickly, log base 3 of x, that'll be okay, 1 over x, times 1 over the natural log of the base, so natural log of 3. Or if you want altogether, 1 over natural log of 3 times x. That's the way I say it, right? So when you do a log, it's 1 over the function, 1 over x, times 1 over natural log of the base. And if you get to here, right, why does it look so funky? It's just a chain rule. It's just a chain rule, right? So we take the derivative of the outside, which is 1 over the inside, times by natural log of the, 1 over natural log of the base. The base here is b. Times by the derivative of the inside, right? That's chain rule, taking times by the derivative of the inside. Well, that's on top. It's a normal derivative, so g prime of x. And then we simplify that, you get this. So that's where it comes from, right? So the log is, okay, 1 over the inside times by 1 over natural log of the base times the derivative of the inside. That's where it comes from. Now, natural log, kind of like the e, is the easier version of this. The derivative of natural log is 1 over x. Why is that? Well, the base of natural log is e. That's why when you get natural log, it'd be natural log of e, which is 1. So that's the only reason why. So natural logs are basic ones. So natural log of x is 1 over x. And then what is this? That's just a chain rule, right? So if we have a natural log, the derivative of natural log is 1 over the inside times by the derivative of the inside. So that's where it comes from. So that's the way the logs work. So I know it's a little more difficult, but log is 1 over the inside times by the natural log of the base, times 1 over the natural log of the base. Best thing to do is just do some examples. Okay, so this first one here. So we want to take the derivative of this natural log. So remember the way natural log works? It's 1 over the inside times the derivative of the inside. Derivative of this guy is 2x. So I could simplify this to 2x over x squared plus 3. Remember that is locked in. Do not cancel out these x's. It doesn't work that way. This x squared plus 3 is locked. Let's look at this one. Natural log of 1 over k squared. So we're going to take, it's a chain rule. We're going to take a derivative of the inside. I cannot take a derivative of 1 over k squared, right? So before I do this, I'm actually going to rewrite it to natural log of k to the negative 2. That way I could just take a smooth derivative and not have to think about it. Right, so derivative that would be, it's a natural log, so 1 over the inside times the derivative of the inside. Derivative of the inside would be, bring it down, subtract 1 off, negative 2k to the negative 3. So I get negative 2k to the negative 3 over k to the negative 2. It's a mess, right? Remember, all the negative powers, they flip. So this is actually just going to be negative 2k squared over k cubed, also known as negative 2 over k. Now remember, keep in mind the negative 2 has its own power. It's the power of 1. That's why it doesn't flip. So that always stays on top. It's the power of 1, but everything else flips. And you get that. Let's look at the log ones. Right? Log base 2 of x cubed. Remember the way we do logs, it's 1 over the inside times 1 over the natural log of the base. Here's 2. Times the derivative of the inside, which is 3x squared. Simplify it all together, you get 3x squared over x cubed natural log of 2. Or you can reduce it to just be 3 over x natural log of 2. Let me erase this so I have some space. So the one right here, same idea, it's a log. So we're going to do derivative of log is 1 over the inside times 1 over natural log of the base times the derivative of the inside. Derivative of cosine is negative sine. Put it all together, you get negative sine x cosine x natural log of 10. Again, free response, that's fine. If we're doing multiple choice, which we'll practice in a second, as you can tell, I would have to probably simplify sine or cosine to be tan, so it'll be negative tan x over natural log of 10. But again, free response, you're good. This is totally fine on free response. This is actually totally fine on free response up here. But multiple choice is probably going to look like this. So let's do some of those. Do a little AP practice this question. So our first one, if f of x equals e to the 2x over 2x, then find f prime. So look at this. Notice what's going on. We are dividing, so we have to do a quotient rule. So there are rules, right? The quotient rule is the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. So in this case, the derivative of the top, that is a chain rule. So take the derivative of the outside, e to 2x, times by derivative of the inside, which is 2. Remember the way e works? Just copy it, times by derivative of the inside. That's essentially what you're doing, right? Derivative of the outside is e is still e, the inside alone, times derivative of the inside. All this times the original times the bottom left alone, so 2x, minus derivative of the bottom, so derivative of 2x is 2, times the top left alone, all over the bottom squared. So the bottom is 2x, so 2x squared. Now again, pre-response, I'm pretty happy with that. Multiple choice, I gotta make it look like one of these guys. So I gotta know my algebra. So let's simplify it. So first let's simplify each one. That's 4x e to the 2x minus 2e to the 2x all over 4x squared. Let's see if there's anything we can simplify. They both have an e to the 2x, and they both have a 2. So let's factor that out. So 2e to the 2x, and that would leave me with 2x minus 1 all over 4x squared. I still don't see it, but I can simplify the 2 and the 4. So I get e to the 2x times 2x minus 1 over 2x squared. And now I see it. Right, so some good old algebra in that problem. Right, the quotient was hopefully pretty basic, just follow the rules. And then you notice it's multiple choice. I gotta match one of my answers, so simplify. Next one. If y equals 10 to the x squared minus 1, then find the derivative of that. So this is another chain rule, but it's with the base, like a basic exponential function. Remember the way we do a basic exponential function? Much like e to the x, we copy it. So 10 x squared minus 1. But then we have to multiply by natural log of the base, 10. And then we times by derivative of the inside. Derivative of the inside here is 2x. Again, we gotta match our answers. Do we see this anywhere? 2x natural log of 10. I do right there. Right? Remember, you cannot combine these. This has an exponent, so it stays the way it is. And you can't combine any of this because that's locked in. So it's just 2x natural log of 10 times x squared minus 1. Next one. If f of x equals sine of e to the negative x, then find f prime of x. So this is a chain rule, right? But it's actually a double chain rule. Right? This right here in itself is still a chain rule. It's e to the negative x. That's a little different than normal. So let's get to it. Right? So f prime, chain rule. Derivative of the outside is cosine. We're going to leave the inside exact all alone. Then we're going to times by derivative of the inside. Now let's look down here. E to the negative x. Derivative of that. So it's a little chain rule. Take derivative of the outside. Remember the way you do e is you copy it. And then times by derivative of the inside. Derivative of negative x is negative 1. So I get negative 1 e to the negative x. Or just negative e to the negative x. I have to look for that in our answer here. And there we go. D. I'm actually wrong. E. I want the one with a negative. So there we go. E. Next one, natural log. So a couple of things here, right? So f of x equals natural log, and then f prime equals 0. So we want to take a derivative, and then we want to plug in 0. So remember the way we take the derivative of natural log? So this is a chain rule, chain rules inherently. Take the derivative out. So the derivative of natural log is 1 over the inside. So 1. So 1 over the inside left alone. Times by derivative of the inside. Now derivative of this inside here, they're all kind of separate problems. Right? So derivative of x is just 1. Plus derivative of 4 is 0. And derivative of e to 3x, we can't talk about it. That's a chain rule. Now we want to get faster at these. So for all we're going to do for e is copy it times by derivative of the power, which in this case is negative 3. So if I simplify that a little bit, I get 1 minus 3 e to the negative 3x all over x plus 4 plus e to the negative 3x. Another one I like to add on a test or quiz, by the way. It's a fun one. Right, and again, I'm not done. I still got to plug in 0. So that's why it's a perfect test question. You plug in 0. You get e, so let me just write it a little nicer. It's 1 minus 3 e to the 0 all over 0 plus 4 plus e to the 0. E to the 0 is 1. So I get 1 minus 3 over 4 plus 1, or negative 2 over 5. Right there. So I got a little messy there, I apologize. But you plug in 0, e to the 0 is 1, so I get 1 minus 3, because 1 times 3 is still 3, On the bottom here, it's a little different, right? 0, 4, plus e to the 0. E to the 0 is 1, though, so it doesn't go away like it kind of does up here. Right? Because over here, e turns into 1, but you're multiplying by 3, so it kind of goes away. Over here, you're adding it, so it's very important. So 4 plus 1 is 5. So negative 2 over 5. Last few. Again, I don't need this anymore. You want to take the derivative of natural log of e of 2x. Now you might be going, okay, so it's a chain rule, blah, blah, blah. Don't forget your basic algebra skills first. We can make this actually a lot easier. First thing I'm going to simplify it. Let's do some algebra. Right? Natural log of e to the 2x. First you can put 2x to the front. And then you get 2x natural log of e. Or just 2x. And don't forget, we still have to take a derivative, so don't give me 2x as the answer. The derivative of 2x? 2. Right? So don't forget algebra. Still big things. So important. I won't let you down. And the same thing with the next one. Right? We could just do this, right? We could go, okay, take the e. I could go like e, which is copy it, times by derivative of the inside. What derivative of the inside is like a natural log, so it's 3 over 1 over the inside times the derivative of the inside. I could do that, simplify it, or do some algebra. Right? This was actually on the summer assignment test. E to the 3 natural log of x squared. Remember, you can move this 3 to the front. Remember, e and natural log do not cancel unless they're right next to each other. So you got to move that 3 to the front. So I get this. These cancel and you get x squared cubed, which is x to the 6. And don't forget, I still need to take a derivative. And the derivative of x to the 6 is 6x to the 5th. Right there. Right? A lot easier than trying to simplify this guy. And you can't run to the same problem, you still have to move 3 over. So, much better to simplify it that way. Okay, one last one. The amount of coffee in the cup in ounces is modeled by b of t equals 16 minus 16e to the negative 0.4 t. Using this model, find the rate at which the coffee in the cup is changing at t equals 5. So, here's a little hint. They say rate is the potential rate of change. We're talking about the derivative when at t equals 5. So basically we want to find b of prime of 5. It's all the same. If we're talking about the rate, it's generally talking about the derivative. So you want to take a derivative of this and plug in 5. So let's take a derivative. Derivative of 16 just goes away. Derivative of negative 16e to the 0.4 t. That is a chain rule. It's an e problem. So remember the way we do e problems is you copy it. Times by derivative of the inside. Derivative of the inside here is negative 4. Negative 0.4, sorry. So we get blah, blah, blah. Whatever negative 0.4 times negative 16 e to negative 4t. Then we got to plug in 5. So a lot of this we plugged into our calculator. Because I don't know what that is at the top of my head. You plug it into your calculator, and then you get an answer. And if you do this correctly, you get, to include, make things 0.4 like they should be, you get 0.8661. And that's your answer.